Lesson 3.9, Distance on the Coordinate Plane, is found on page 135 of your big book. Essential question: how can you find the distance between 2 points that lie on a horizontal or vertical line on a coordinate plane? The map of Foggy Mountain Park is marked on a coordinate plane in units of 1 mile. So in other words, each of these squares is 1 mile. 1 mile that way, 1 mile that way, and so on. There are 2 campgrounds in the park. Camp 1 is located at -4.3. Camp 2 is located at 5.3. How far is it from Camp 1 to Camp 2? So we're going to figure out the distance on the coordinate plane. Graph the points. The points have the same x or y coordinate. Here's our x coordinate, -4 and 5, so it's not our x. 3 and 3. So they have the same y coordinate. So they are located on a horizontal line. Find the horizontal distance from Camp 1 to the y-axis. And then, all right, so find the distance from between the x-coordinates of the points -4 to the, and the point -4, 3, and the point 0, 3. The distance of a number from 0, going back a couple of lessons here, is the absolute value. Distance is always positive. Distance is always positive. So it's the absolute value of the number. So from -4 to 0 is a distance of 1, 2, 3, 4, which is positive. Remember that distance is never negative. You can find the distance between a negative number and 0 by using absolute value. All right, so the distance from -4.3 to 0.3 is the absolute value of 4, which is 4 miles. 1, 2, 3, 4 miles. Find the horizontal distance from Camp 2 to the y-axis. So we're going to find the distance between the x-coordinates of, where's Camp 2? 5.3. So 5, 3, and 0.3. The distance from 5.3 to 0.3 is the absolute value of 5. The distance between 5 and 0 is 5, right? So it's 5 miles. Okay, now, whoops, I'm not quite on. Let's fix that. All right, so now we're going to add the total distance. So we're going to take this absolute value and this absolute value, which is 4 plus 5, and we end up with 9 miles. So the distance from Camp 1 to Camp 2 is 9 miles. Let me show you that on the coordinate plane as well. Okay, so if we go back up here and we graph, let's see, -4, 3, which is right there, and we graph 5, 3, which is right there, you're going to find out that the answer is still 9. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. So the distance between these 2 points is 9. Okay, so if you can graph the points on a coordinate plane and just count, that's the easiest way to solve this. All right. In the problem on the previous page, you used absolute value to find the distance between points in different quadrants. You can also use absolute value to find the distance between points in the same quadrant. Find the distance between the pair of points on the coordinate plane. Points A and B. Look at the coordinates of the points. We have, where's A and B? We have A here and B here. So before we even get started, let's look at this. This is half, right? What are my points? Look at the... Okay, so this is, oh, no, it's not a half. I see. They're doing count by twos. So 2, 4, 6, 8. So this is 1, 2, 3, 4, 5. So I already know the answer is going to be 5 before I get started, okay? All right, so in this instance, the y coordinates of -6 and -6 are the same. So the y coordinates of the points are the same. So the points lay on a horizontal line. Think of the horizontal line passing through A and B, points A and B, as a number line. So think of this like it's a number line right here. So from -9 to -4 is 1, 2, 3, 4, 5 spaces, right? Now the way you can do this with an algorithm to find the distance is the distance from 0 to 9, the distance from A to 0, point A to 0 over here is 9 units, the absolute value of -9. The distance from B to 0 is the absolute value of -4, which is 4 units. Subtract to find the distance. If both points are in the same quadrant, and you're using this method, then you have to use subtraction. So subtract to find the distance from A to B. So we say 9 to 4 is 5 units. So the distance from A to B is 5 units. All right, points C and D are a little different because we're working vertically this time. But that's the only difference. All right, look at the coordinates of the point. This time, if we look way back up here at C and D, it's the x coordinate that's the same. X is 8 in C and D. So the x coordinates of the points are the same, so the points lie on a vertical line. Think of the vertical line passing through C and D. Once again, C and D are in the same quadrant. Therefore, when we get down to the algorithm, we will be subtracting again. So if they're in the same quadrant, we subtract. If they're in different quadrants, we add. All right, here we go. Find the distances from C and D from 0 on the vertical number line. The distance from 0 to 10, from 0 to 10 is the absolute value of 10, which is 10 units. The distance from 0 in point D to 3, the absolute value of 3 is 3 units. So now we're going to subtract 3 from 10, and it's 7 units from C to D. So the distance between C and D is 7 units. Now once again, if you can just graph it on the coordinate plane, you can just count. So these are our 2 points. In fact, I will highlight it so you can see it better. Okay, we're talking about the distance between these 2 points right here. It's a vertical line. Okay, and remembering we're doing counting by twos. So when I go halfway through, that's a 1. So 1, 2, 3, 4, 5, 6, 7. You can just count to get the number, to get the answer if it's on a coordinate plane. And again, it matches my number here, 7. Okay, so our notes. 3.9 distance on the coordinate plane. Here are our notes. Distance is always positive. It never comes out negative. So here are some examples. If they're in different quadrants, you get to add the two absolute values together to get your answer. If the points are in different quadrants, then add. If the points are in the same quadrant, then you subtract. So the absolute value minus the absolute value of -4 minus the absolute value of -1 is 3. And again, if you can just graph it, you can count.